In this video, we will practice factoring a variety of polynomials, including these binomials over here, and this stuff over here. We're going to factor all four of these things. Okay, it's a variety, so something for everybody. Now, the first step of factoring. What is the first step of factoring, no matter what? The first step of factoring is to look and see if there is a common factor. GCF stands for greatest common factor. If there's a common factor, you want to pull out the GCF. Looking at 8 and 27, there's nothing that divides into both of those. So there is no GCF. So now we can think about what else there could be. Now, this is a binomial, two terms. There are two possibilities. Is this the difference of squares? Or is it the difference or sum of cubes? These are the only two ways to factor a binomial if there's no GCF. Difference of squares or difference of cubes. But for cubes, it could be difference or sum. Well, this 3 right here kind of gives you a clue that it's not difference of squares. It's probably difference of cubes. Now, looking at that 8 and 27, let's think about perfect cubes. It's helpful to use the table feature of your calculator. If you type in x to the third power, this is going to give us a list of perfect cubes. I'm just going to start from 0. Okay, so this is saying 1 to the third power is 1, 2 to the third power is 8, and so on. Let's see, let's be bigger if I do this. Yeah, okay. 2 to the third power is 8, 3 to the third power is 27. So 1, 8, 27, these are perfect cubes. So notice 8 and 27 are both perfect cubes. 8 comes from 2, 27 comes from 3 to the third power. So this is definitely the difference of two cubes. So that's the strategy we're going to use. Now, once you recognize that you have the sum or difference of cubes, you need to have memorized that you're going to have a binomial times a trinomial. 2 terms here, 3 terms here. The binomial will just be the cube root of these two terms. The cube root of 8 is 2. The cube root of x to the third power is just x. I'm just going to keep that minus. The cube root of 27 is 3. Now when I'm saying, whoops, that's not the right button. When I'm saying cube root, I'm saying 8 came from 2 to the third power. So the cube root of 8 is 2. 27 came from 3 to the third power. Okay, so that's our binomial. Now how about the trinomial? Well, if you take these and you square them, it will give you the beginning and the end. So if I take 2x and I square that, that's going to give me 4x squared. Got to square the 2 and the x. If I take negative 3 and square that, that's going to give me positive 9. So that just leaves the middle. For the middle, you multiply these together, but you do the opposite sign. So since this is negative, I will have positive here. 2 times 3 is 6. So 2x times 3 would be 6x. And that's how you factor the sum or difference of two cubes. This trinomial will never factor further. Okay, let's take a look at this one. Whenever you have 4 terms, you should consider doing grouping. If you really want to tell whether or not grouping is going to work, look at these two and divide them. All right. I like to do the one on the right divided by the one on the left. 24 divided by 12 is 2. Okay, now over here on the right hand side, I've got -2 and -1. If I do -2 divided by -1, guess what? That is also 2. So if you divide the two coefficients and you get the same number, that tells you that grouping is going to work. Okay, so now let's go back and actually do it. So if you look at these first two terms, this first pair, there is a common factor, 12 and x squared. So 12x squared goes into both of these. Now imagine dividing by that GCF. Imagine dividing by 12x squared here and here. The 12s would cancel. X to the third power divided by x squared is just x. 24 divided by 12 is 2, and the x squares would cancel. So we would have this. Now, on the right hand side, we are also going to do the same thing. For grouping to work, you're going to need the parentheses to be identical. So let's start off by assuming that this is going to be x plus 2, and then we'll see. Now, in front of this, x is an invisible 1. So I'm going to go ahead and think of this as -1x. And that's helpful because that's what I'm going to put in front of this set of parentheses. Now imagine that I did the distributive property with -1. -1 times x would give -1x. -1 times 2 would give -2. So it is equivalent. Now that I have these parentheses that are the same, x plus 2 is a common factor. So therefore I can pull it out front. Alright, I can just pull those right away. Now that's going to leave behind 12x squared minus 1. Okay, so we have factored it so far one level. The question is, will it factor any further? Well, this is linear, so you can't factor that anymore. But looking at this, it's quadratic. I see that it's squared, so there's a chance it will factor more. Now, see that x squared minus 1? If it had been x squared minus 1, I could have factored it as the difference of squares. Okay, these are equivalent. But with that 12 in front, no can do. 12 is not a perfect square. If instead of a 12, imagine this had been a 4. Then I could have done 2x plus 1, 2x minus 1. 4 is a perfect square. But again, with the 12, there's nothing you can do. This is not a perfect square. It's unfactorable. That means this is the final answer. Okay. Now, looking at number 5. Again, this is a binomial. Notice that it is the difference. Alright, difference means subtraction, so I have a difference. 25 is definitely a perfect square because that's 5 squared. Y to the 4th power is also a perfect square because y to the 4th power is y squared squared. Okay, anyway, this is the difference of two squares. So we can use the pattern that we've learned. Y to the 4th power would be like y squared times y squared. So it'll be y squared plus 5 and y squared minus 5. Now, can either of these be factored further? No. Neither one is the difference of two squares. So there's nothing else you can do here. Alright, let's do one more problem on this video. What is the first step of factoring? Looking for the greatest common factor. I'm mentioning that now especially because there is one. 4 goes into 4 and 32, and they both have at least one x. So the GCF is 4x. Okay, Now, if I take that GCF and I divide with it, that's going to tell me what goes inside. The 4's would cancel. X to the third power divided by x would be x squared. 32 divided by 4 is 8. And the x's would cancel. So, this is what you have once you pull out the greatest common factor. The only question is, can I factor this any more? Well, as we've discussed several times on this video, our only hope is that this be the difference of two squares. This is neither. It's not the difference, alright, because that means subtraction, and 8 is not a perfect square. So this cannot be factored. So this is the final answer.